Hello, and welcome to my video presentation. My name is Nathan Rusnak, and today we will be examining the unique ecological organization and phenomenon of this small microclimate, and how topography influences ecological and biological diversity within this microclimate. Plots studied over the course of the semester occupy space within the North American Western Interior shrublands and woodlands biome. Although the plot studied could be considered a tree island within the Palouse, mostly known for its rolling wheat fields and abundant crop nature, the adjacent north and south slopes of the plot studied are very diverse in vegetation and coverage percentage. This is Kamiak Butte. Kamiak Buttes elevated above the low soils found in much of the Palouse. This is the major influence on the vegetation that's able to grow within the microclimate. Here's an aerial view of Kamiak Butte showing the south slope and the north slope. This aerial view provides a clear understanding of the differences between the south and the north slope. Let's focus on the north slope. To fully understand the difference in vegetation between the north and south slope, we have to consider topography and how Kamiak Butte is affected by differences in sun exposure on the north and south slope. The city of Pullman, Washington is located on the 46.7298 degree north latitude, meaning that for most of the year, the sun is located in the southern part of the sky. This has direct correlation to the amount of vegetation that is on the north slope compared to the south slope. Let's dig into this a little bit deeper. We're now looking at a topographic map of Kamiak Butte. Located on the upper part of the green section is the north slope, and on the bottom the south slope. It's important to note and remember that for most of the year, in the fall, winter, and spring, the sun has direct sunlight on the south slope. The ridgeline at the top of Kamiak Butte leaves the north slope in indirect sunlight. This indirect sunlight creates long shadows and cooler temperatures. In the wintertime, snow that's piled on Kamiak Butte melts slower and much more gradually, creating a layer of water in the soil where vegetation thrives. On this table, we see abundance, dominance, and distribution of indicator species by layer in the plant community. Community 1 is the north slope, where community 2 is the south slope. If we look at the different tree species, it is very clear that the north slope occupies more in dominance, abundance, and distribution than the south slope. By studying species distribution, we can also make assumptions about the reproductive cycles of each species. When examining the north slope's tree species, you can see that the Douglas fir has a positive reproduction rate compared to the ponderosa pine and the western larch. If we switch over to community 2, however, on the south slope, we can see that abundance, dominance, and distribution are scarce. The ecological diversity is substantially less than that of the north slope, and this we can attribute to the direction of the sun and extreme weather events that occur more often on the south slope. It's important to consider species type when we're comparing the north and south slopes, though. Species type and abundance is different on both slopes. While the north slope is abundant in tree and shrub species, the south slope is abundant in grasses. Similar to the first table we looked at, this table shows community 1 and 2, the north and south slope, and the different species of shrub and herb layers. On the left, community 1, we have the north slope. Here you can see ninebark, snowberry, and Oregon grape as dominant features within the slope. In Community 2, we can see evidence of snowberry, but this is really the limited factor in the shrub layer. More so, we can see the herb layer with wheatgrass, annual grasses, and balsam root as dominant features within the landscape. It's also interesting to note that while visiting Kamiak Butte and examining the south slope, the shrub layer, where we found little amounts of snowberry within our plot, grew dominantly underneath pines and other trees in the area. So although the table shows the shrub layer having minimal amounts of snowberry, this is limited to the plot that was examined. It is very possible that other shrub layers could be growing outside of the plot area that we measured. The Palouse is known for its one-of-a-kind rolling hills and wheat fields, but the Palouse's microclimate hides a hidden gem of ecological individuality and biodiversity in Kamiak Butte. The location of the North Slope and the path of the sun create an incredible microclimate on Kamiak Butte that allows for different environments in one geographic location. The abundance of vegetation on the North Slope is only capable because of the topography the butte has in correlation with the sunlight. The difference in vegetation between both slopes creates two different microclimates, separate from the macroclimate of the Palouse, and with it provides two individual landscapes with incredible diversity that should be protected for time to come. Thank you for tuning in. I hope you enjoyed my presentation on Kamiak Butte.